Hi everyone. Welcome back to my channel. This side Priya Bhatia. And in this specific discussion, we will be talking about a very interesting topic. Many people right now are really confused between, how to progress in a project with respect to ML versus Gen AI. So, in this specific part of the discussion, I'm taking one specific session with the learners in a live mode, and I'm talking about this specific topic, that how you can segregate the ML workflow or the pipeline uh, as comparable to Gen AI workflow. So in this part of the discussion, I am attaching the recordings for that. Listen the session till the very end. You will get a lot of insights that how the workflow of any ML specific project looks like when you work in the companies versus how the workflow of Gen AI specific projects looks like when you work in industries. Now, see, simple thing, simple fact over here is, फर्स्ट ऑफ ऑल यू शुड हैव अ क्लियर अंडरस्टैंडिंग कि कौन सा प्रोजेक्ट मशीन लर्निंग के प्रोस्पेक्टिव में आएगा और कौन सा प्रोजेक्ट जेन के स्पेसिफिक हमारा होगा. Whenever you are dealing with a simpler sort of data, especially the numeric numbers, for example, till so far banking domains, fintech domains, especially the consultation firms, when they are dealing with a, I would say, numeric data, till so far machine learning is the domain which is currently working. Inside that, especially the ensemble based models like XGBoost, Random Forest, you will observe people are using it till so far in a very frequent mode. On the other hand, when we talk about Gen AI, there the purpose is completely different. Purpose is to generate something out of it. For example, you are using Chat GPT right now, you are using Perplexity right now, the platforms like Gemini. So all of these are the best examples of generative AI. So there I enter a prompt, and based on that I am able to receive the responses accordingly. So when I'm talking about Gen AI based application, you will observe that over there, my main focus is to generate images, videos, text, audio, anything like that. So in this specific part of a discussion, try to listen the session till the very end, where I will talk about one by one how the ML workflow looks like versus how the Gen AI workflow looks like. Uh, I am the person who have worked in both the projects in a deeper way. ML is something from where I started my data science journey. Gen AI is something which I was working currently with respect to a current company of mine. So I have invested almost, you can say, 2 years in ML and almost 2 years in Gen AI working in the companies. So I'm sharing my experiences over here. Still, if you feel there is some doubt, there is some confusion, you can always let me know in the comment section of this video. Please make sure that once you understand the entire video, you will document your learning. You will try to share that learning on LinkedIn. The more you share, definitely you will get more reach, and I will also check your post if you will tag me, and I will definitely comment that down in your LinkedIn post as well. So please put an effort once you get the understanding of the concept in terms of spreading with the other community as well. With that, let's get started. When we talk about machine learning, what do you understand by that? What do you think that which specific category of problems we are solving under machine learning? What do you think about this? So, can we say that machine learning, for example, if let's say this is the bigger scope of AI or artificial intelligence, where we are saying that we will be having end to end machines, we will be having the machines which will be able to take the decisions without any human intervention, right? Without any human intervention. So if there is any machine which will be able to take the decision without any human intervention, So we can consider that it's a AI based machine. It's a artificial intelligence. So when we talk about self-driving cars, so we can consider this as a very good example of AI, where there is an end-to-end product that we will be having, which will be able to understand when to apply a brake, when to change the gear, uh, and when to apply accelerator. So all of these things we will be having in terms of AI. Inside AI, we have different domains. Machine learning is one of them, and we can consider this as a subset of artificial intelligence. So, when we talk about machine learning, over here, the focus will be to tackle the historical data. And from there, we need to understand the pattern and understand the pattern. So, we need to tackle the historical data. Model will try to understand the pattern, and then definitely again make future predictions, make future predictions without any, we can say, human intervention. Human intervention. So that's the whole point that we will be having, right? Now, when we talk about machine learning, we have understood that okay, it will be able to learn the patterns from the historical data, understand the pattern, and make the future predictions. That is fine. Now, if we talk about any traditional programming, the what is the meaning of traditional programming? The way we used to write the code in DSA. I hope everybody knows that, right? So what we do over there in the traditional programming, the main part was the main part was the computation. So over here, our main focus is that let's say if we have data and the program, if we have a data and program, based on that, it will try to do a computation and we will be able to achieve the output, or we will be able to achieve the results for it. You know? So, for example, let's say you will write any DSA specific code. So, for a given problem, you will write the Python code and you will be having some test cases. You will try to check that. So, based on that, you will try to get some result. For example, let's say if you are adding two numbers, so you will write a program, you will write a logic, you will give the data, which is let's say 2 plus 3, 2 and 3. It will do the computation and we will get the output as 5. Are you getting my point? So this is what we have as a concept under a traditional programming. This is the concept we have under traditional programming. But when we talk about something called as machine learning approach, when we talk about the concept under machine learning approach, so what usually happens over here is that in machine learning, computation will happen. It's not that computation will not happen. Definitely computation will happen. But over here, what we are feeding as an input is the data and its corresponding results, which we also called as labels. And as an output, what we are getting is a end-to-end program of it. Are you getting my point? So my model, when I'm saying it is doing a computation, it means that it is actually learning the patterns. And once it starts learning the pattern, according to that, it will be able to give me the program corresponding to it, and things will happen like that. So that's the main difference between what we called as traditional programming and what we are doing in machine learning approach. Is this clear to everyone? So over here, the programmer will write some explicit rules in traditional programming, and based on that, we will be getting the output. In machine learning approach, it's not the core responsibility of a programmer. Over here, we will be having the labels, and based on that, implicitly it will process and give us the Python program correspond to it. Are you getting my point? Is this clear to everyone? Is this clear? So if I will try to give you a formal difference between these two, let me try to first of all create one folder for today. So this is a separate module we have, and we can rename this module as Data Science and ML Lifecycle. So over here, let's create the first folder, which is about problem definition and life cycle understanding. So if I will try to create one Google Doc for this, so can we see this is the main difference that we have covered up just now? See this? So traditional programming, a programmer writes fixed rules for every case. In machine learning, the system learns its own rules and patterns by analyzing a large data set of examples. Where are these rules stored? In the program code. Over machine learning, it is stored in a model which is built from a data, which actually captures the patterns from a given data. How it works, we have a data and a program. Combined together, it will give us an output. In machine learning, we will be having a data and the correct answer. Based on that, it will form a model. And based on that model, we will get the predictions out of it. Then we have a flexibility. It's a rigid, must rewrite the code to change the rules. In machine learning, it is adaptive. The model can be retained on new data to adapt to the changing patterns. So is this clear? Is it clear? So that is the main difference between what we do in traditional programming versus what we do in machine learning. I hope all okay till so far, right, everyone? How a machine identify or predict if there is any change in pattern. We'll talk about this in a life cycle part, Ajitish. So you have to wait for a minute. Uh, okay. I think remaining things are fine. Great. Let's move ahead now. Perfect. So what we have understood till so far, we have seen what is actually machine learning. So we have seen it's a subset of AI, which is basically tackling the historical data and understand the pattern of it, and then tries to make a predictions for the future part without any human intervention. This is fine. Now let's move further. how the entire machine learning ecosystem will work. Let's try to understand that. So over here, what happens is, I will give you one scenario, and based on that, I think we will be able to get a fair understanding of all these things. Let's say you are solving a problem, a problem in which, let's say, you need to detect that whether the patient is diabetic or not. Okay, that is the main use case which you are solving. So over here, let's suppose that for this specific problem, you will be having a lot of input features. I think I have one data set also, which is similar to this. Let me have a look onto it if I have that. Um, hmm. For example, this is the data that we will be having. Let me try to copy it for today's folder. Oh, okay, it is done. Now, if you can see in this specific data, let me open this file. In this specific data, this is the input features we have. Can you see over here? We will be having pregnancies, we will be having glucose, BP, skin thickness, insulin, BMI, diabetes pre-degree function, and the age. And based on these features, we have one specific column called as an outcome, which is actually giving me the value as 1 and 0. 1 means that a patient is diabetic, 0 means the patient is non-diabetic, or in other words, we can say the patient is normal. So when you try to copy this and you will try to paste it over here, uh, so you will observe that we do have some sort of input features. These are also called as independent features. These are also called as independent features. And this outcome is something which we called as an target feature. The output is something which we call as a target feature. So what is happening over here is that based on this feature F1, feature F2, feature F3, feature F4, feature F5, feature F6, feature F7, feature F8, this target value of Y will be predicted. Now, whenever you will be having in your data the target column available to you, that is what we call as supervised problem. What is the meaning of supervised problem? What is the meaning of supervised problem? So in machine learning, we will be having two categories. One is called as supervised machine learning. Another one is called as unsupervised machine learning. What is the meaning of supervised machine learning? It means that your target column will always be available. So when your target column is available, that specific portion is what we can consider under supervised ML. Is it fine? Now, in supervised, we have two categories. One is what we call as classification. Another one is what we call as regression. So when we say classification, it means that over here, our main job is to classify the two entries, whether the patient is diabetic or non-diabetic, whether the uh, person will go for a play or not, whether the rain will happen or not. So all of these things, all of these specific use cases comes under a category of a classification task. Is this something clear to everyone? Regression means that over here, so in the classification, you will try to predict the class. You will try to predict the class, or what we can say, a discrete entry. In regression, our main focus is to predict the continuous values. Our main focus is to predict the continuous values. For example, we can take an example of house price prediction. When we talk about a use case of house price prediction, obviously over here we will have to uh, display, we will have to print, we have to uh, predict that what is the price of the house, what is the weight of a person, what is the height of a person. All of these are the examples of a regression scenario. So one thing, what is supervised machine learning? It means that if we have this kind of a data where target column is available. Another thing, under that we have two classes, classification and regression. When we talk about classification, main focus is to predict the class. When we talk about regression, main focus is to predict the continuous values. Is this fine? Is this okay? Yes, Harsh. Classification means categorical predictions, discrete predictions. Regression means continuous values prediction. This is a class, right? Outcome, whether the patient is diabetic or not. So over here, if I'll ask you what is a class over here, this will be either 1 or 0. This is the meaning of a class. So over here, when we say this example, we can see that it will be either 1 or it will be 0. So we have two classes. 1 means that the patient is diabetic. 0 means the patient is not diabetic. Regression means, yes, it's not numerical. Numerical to 0 or 1 bhi hota hai. Numerical to 0 or 1 bhi hota hai. It is about predicting a continuous number, right? Predicting a continuous number. So is this clear? First of all, you have to understand what is supervised machine learning, and then further its two components, classification and regression. Tell me if till so far everything is clear or not. Then we will proceed further. Is this okay? When we categorize as supervised learning, I have mentioned everything over here. When target column is available. Target column example I have shared with you with the proper CSV file. Done? So over here, what we have understood till so far, we have seen, first of all, what is machine learning. We have understood that the very first component of machine learning is supervised machine learning. Why it is called supervised? Because over here, we have a target column which is available. For example, I have given you a real-time example of a diabetic data. where we have a target column of outcome which is given to us. Our main job over here is to feed this input features, which is pregnancies and from pregnancies to age, and try to predict the outcome of it. So this is what we have done as well. So over here, data is something which is a list of the input features that we have, and result is something which you can consider it as a target column. And based on that, it will try to map and give us the set of rules, set of program, which will do a better mapping of these input features to the target column. Now, once it is done, we have seen that we can have two types of machine learning, supervised machine learning categories based on what is the kind of a prediction we want to do. One way could be that where we are saying that our predictions will be the class. It could be 0, 1, it could be yes, no, it could be true, false. So when you have distinct classes available, it will be a part of a classification job. But when our main focus is to predict the continuous entry, continuous value, then it comes under the part of regression problem. Yes, yes, Megha, that's true. Is it fine? Is it okay? Shall we move further now? Everyone, can I get a quick confirmation? Is this okay? चले आगे. So now we will understand कि this is a supervised part, but it could be a case where we don't have a label data. We don't have the target feature or target column available. So there is one sort of category. For example, there is a very famous data called as small customers data set. So if I will try to showcase you this specific data, let me try to download this and showcase to you. You can see, let's say we have a list of customers, we have the gender of that customer, we have the age of a customer, annual income, and the spending score. Now, let's say based on this data, I want to uh, I want to segregate these customers into three classes. Maybe one set of customers who are premium, who used to do a lot of purchases from the mall, whose spending score is very good. Then we have a second class of customers whose spending is on an intermediate level, and then we have a lower level of customers whose spending score or annual income is lesser. So if you are having this kind of a problem where you have the features, input features available, and you want to do a task of customer segmentation, then we have a concept called as unsupervised machine learning. So what is the meaning of unsupervised machine learning? It means that over here, the target column is unavailable. Over here, the target column is unavailable. So we will be having a class of customer. Maybe I want to do a segmentation of customer. So a very interesting application is customer segmentation. Okay? So we have a list of features, but based on a similar pattern, it will try to do the grouping on its own. It will try to aggregate the similar patterns over there, and it will try to segment the overall set of customers data into three categories. That's what we call as a customer segmentation. Is this okay? Is this clear to everyone? All good? Is this fine? चलें आगे. Is this clear? What is the meaning of unsupervised machine learning? Simple speaking, in your data, the target column is not there. So in the above case, we have seen that when the target column is there, so that will be classified as unsupervised. When the target column is not available, whatever you want to predict, then it will be classified as a unsupervised machine learning, simply. Over here, there is a concept of something called as clustering. Clustering means we will do a grouping of data items or data records as per similar set of features. So that is what will come under a clustering concept. Customer segmentation is one of them, application of it, where let's say you want to classify or segregate your customer into, let's say, three categories, as I have mentioned, maybe a premium one, intermediate one, and low category one. This is the overall point. Is this okay? Is this clear to everyone? Clustering is a technique. Clustering is an algorithm that we will learn under unsupervised machine learning part. In machine learning, for example, there is a concept of k-means clustering algorithm. There is a concept of DB scan, hierarchical clustering. So all of these are the algorithms that we will cover up. So we don't have as such categories in unsupervised, just like the way we will be having in supervised, depending upon the predicted part. All good? Is this okay? Everything is clear till so far? Shall we move further? चलें थोड़ा सा आगे बढ़े. तो अभी तक क्या समझा हमने? हमने देखा कि मशीन लर्निंग क्या होता है. हमने देखा कि मशीन लर्निंग कैसे ट्रेडिशनल प्रोग्रामिंग से अलग है. हमने देखा कि मशीन लर्निंग के कितने फ्लेवर्स हैं. देयर आर टू मेजरली वी हैव डिस्कस्ड, सुपरवाइज्ड एंड अनसुपरवाइज्ड. सुपरवाइज्ड में हमने देखा दो फर्दर सब कैटेगरीज होती हैं. एक हम बोलते हैं क्लासिफिकेशन और एक हम बोलते हैं रिग्रेशन. एंड फाइनली हमने अनसुपरवाइज्ड मशीन लर्निंग के बारे में पढ़ा. जैसे कि एक ऐसा स्पेसिफिक डेटा जिसमें हमारे पास टारगेट वैल्यूज अवेलेबल नहीं होती. तो उसमें जैसे मान लो अगर हमें कस्टमर सेगमेंटेशन करना है, मेरे पास एक मॉल डेटा है, बेस्ड ऑन दैट मुझे उसको सेग्रीगेट करना है एक प्रीमियम, इंटरमीडिएट और लोअर लेवल कस्टमर्स के बीच में. राइट? ऑल गुड? इज दिस ओके? थोड़ा आगे बढ़े आप. जस्ट गिव मी अ सेकेंड. Is this okay? Shall we move further? Yes, all good. Now, I think it's the right time that we will start discussing about the end-to-end life cycle of any machine learning project. So let's talk about the end-to-end life cycle of any ML project. ठीक है? Now, The very first thing, whenever we will start our any machine learning project, is to understand, spend some time and understand the problem definition. So over here, depending upon what specific project we want to solve, we want to handle, we want to take care of, we will try to understand the problem. We will try to deep dive into it. We will try to understand the use case and its impact in a real time. For example, let's say we have a problem of customer churning. I hope everybody knows what is the meaning of churning. Everybody knows that. Churning means the customers who will leave the service from a company due to any XYZ reason. So, what I want is I want my customers to churn at a very lower rate, or they should not churn at all. Because gaining a new set of customers is very difficult. But if we will be able to retain the previous customers, it's a very good thing that we can do for our company. Let's say today I am opening my own edtech firm, and you guys, as a learner, are my customers. What I want is I want that I will be able to give you a best deliverable, so that if in future I will launch some other new product on my website, you guys will come, you guys will wait, and you guys will join that specific product. Are you getting my point? So now over here, you have to first of all deep dive into the problem definition. You have to understand the impact of that. You have to understand and gain the domain knowledge of it. Similarly, if let's say you are solving a problem of diabetic classification part, so over here the main focus of us is to I would say work around with a scenario where we will be able to properly in an accurate way classify that whether the given patient is diabetic or not. Now this specific problem is very important in terms of accuracy, because even a small mistake by my model can impact the lives of the people, right? So that is the main reason why this specific use case, this specific problem is sensitive. In fact, all the healthcare problems are very sensitive. So maybe over here, a proper healthcare domain knowledge is required. In fact, in order to understand any problem definition or a use case, if you have a good understanding of the domain problem, or if you have a good domain expertise, that would be always a plus point. That would always be great. Is this okay? So the first pointer is the problem definition. Now, once we will be able to understand the problem, the second step is based on that problem, based on that use case, we have to collect the data. So the next step is data collection. So we need to work on collecting the data in an appropriate way. Now, this data collection might include various things. For example, maybe there is some API call which you have to do to fetch the data. Maybe your data is available in any database, and you might need to use some SQL scripts to access them. Might be your data is available in the form of CSV file, or maybe the Excel file, and the clients directly share that specific data with you all. So there are multiple ways, multiple techniques to collect this data. Okay? So data collection is the second important thing that we're supposed to do. So once we understand the problem, data collection is the second key component. Is this clear? Is this okay? चलें आगे? Is it good? Now, once the data will be collected, what do you think will be the next step? Let's suppose you will be able to collect the data. The next step is uh, that you will be able to pre-process the data in a wonderful way. What is the meaning of data pre-processing? Yes, it's kind of cleaning, it's kind of transforming, or maybe splitting the data. So over here, our main focus will be to convert that specific data into a cleaned way. Now, why is this important? Because you can understand if your data is not clean, your model will learn from that specific data only. So if it is not cleaned, it will not able to give appropriate results or the predictions or the accuracy for the same. So that is the main reason data pre-processing is very critical and important stage. Okay? Problem definition, someone is saying to repeat. So problem definition is something from where you will start your project. As per the meetings with your clients, with your stakeholders, you have to understand the problem in a critical way. I have given two examples of the problem statements. For example, you're working with a customer churning project. So you have to understand ki what actually I want as an outcome. It's a classification part where I have to predict that whether the customer will leave the service or not. What is the impact of it? If the customer, my model is saying will leave the service, so I have to think about the ways, the recommendations that how can I make sure that the customer will not leave my service. When I talk about the concept of diabetic classification, I have to think about how my model will be able to explain the predictions, how my model will be able to give me the accurate results. So with respect to every change of problem, you will be having a different level of domain expertise which will be required to solve that problem. So problem definition, as per the problem definition, we have to collect our data. As per the data collection, we have to pre-process that data. Is this clear? Till three steps? Till three steps, are the specific pointers clear to everyone? Now, once you will be able to pre-process the data, the next job is to do EDA, exploratory data analysis. What is the meaning of exploratory data analysis? It means that in this specific step, you will try to analyze the data. You will try to understand the patterns. You will try to understand the relationships of a given data. So you will try to understand the pattern and relationships of a given data. So that is what you will do in EDA. Now, one most important thing that when you work on this data collection part, you should have a very good expertise on Excel tool, because it might be the case that your data is available in Excel and you might have to tackle from there. You should have a very good expertise on how we can make sure, how can we call the APIs and all those things. You should have a very good expertise on the databases also. Maybe any one of the database, if you know about MySQL and you can write all the SQL based scripts, that would be great. And this specific uh, tech stack will help you to get a deeper level of understanding and to create end-to-end projects of it. So that is the main reason why I'm saying you should have a very good understanding of Excel API DBs. When we talk about data preprocessing, over here, if you will ask me, Priya, what is the specific tech stack which will be required? I would definitely say that statistics is one of them. I would definitely say that statistics is one of them, right? Because without mathematics, you won't be able to understand, you won't be able to pre-process the data, clean the data. And in fact, when I'm saying EDA part, Again, stats plays a very important role. But obviously, apart from stats, when I'm saying I want to understand the pattern, I want to identify the relationships, I need few more things apart from statistics, because stats also I have to implement. It's not a numerical problem that I have to solve. For that, you need Python programming to implement the code, to check whether the things are working fine or not. In the Python programming, whatever be the topics that we have covered up till so far, whatever be the modules that we have covered up, like NumPy, Pandas, Matplotlib, Seaborn, all of them are the core of doing this pre-processing and EDA. So NumPy, Pandas, Matplotlib, and Seaborn. I would say these are the core topics that one should gain a deeper understanding in order to have a deeper context of all these stuffs. Is this something which is clear to everyone? Is this something which is clear to everyone till EDA portion? What is the tech stack required and what are the steps that we will be having? And this is a generic pipeline. This is something which you will follow in almost all your ML projects. It's not that for any one specific project I'm talking about over here. Now, once you will be able to perform a EDA, it means that now you have a clean file. Now you have a very good intuition about that specific file. You know about all the patterns and relationships in a given data. Next stage will be to build a model. So model building will come into picture. Model building will come into picture. Now, what will happen inside this model building? Now, just few minutes back, I told you that we do have two different concepts. We do have two different approaches to solve any machine learning algorithm. It could be supervised, it could be unsupervised. In supervised also, we do have two further subcategories. Either we are focusing on a classification task or we are focusing on a regression specific task. Do you guys remember that? Do you guys remember that? So model building means depending upon what type of data you are having, whether that data is a labeled data or it's a unlabeled data. And if it is a labeled data, whether this labeling or the prediction is based on a continuous value or it is based on a categorical value. है ना? Based on that, we will decide which specific flavor or which specific type of model we will use in machine learning. There are so many different models we have in machine learning, which we will cover up under ML module specifically. For example, you might have heard of linear regression, logistic regression. We have ensemble models like random forest, XGBoost. Depending upon what specific problem you are solving, whether it comes under a supervised part or it comes under a unsupervised part, based on that, we will be trying to build a end-to-end model. Is this something okay for everyone? So model building is done. Fifth step is completely done. Shall we move further? How many models do we have? I mean, I never counted it down, but you can imagine 10 to 12 at least we have. So depending upon what kind of problem we are solving, we can apply that specific variety of algorithm. Now, once you will be able to build a model, what does that mean? I mean, when we say that now I have a model ready with us, I have done with my model training part, it means that now you are saying that my model has now understood somehow all the patterns of the historical data that you have fed. है ना? So now my model has that program in it. Few minutes back that we have covered up. Ki when we will give data and results, so it will provide a program. Program means over here it is able to have some interesting patterns in it. Getting my point? So it means that now my model is having some set of rules, some set of patterns, and based on it, that only the final predictions will be done. Model means is it like, you can say Gemini, Chat GPT, all of them are the models only. But every model is having a different task. So it depends on the data feeding part, what specific data you have fed, and based on that, your model will learn something different. It's like you are learning data science, so you will become in future data science expert. So you are training your model, your mind in such a way. There is someone who is having an interest in web development, so he will take that specific expertise. There is some other person who is having an expertise in surgeon as a doctor. There is someone who is a gynae. So depending upon what actual your interest is, you will start feeding that specific kind of information. And that's why we will be having different professions. Same thing is happening over here. So depending upon what type of data you are feeding to the model, you will be having different types of models available. Exactly. Accuracy will be different for every model. So we have to search for that specific model which is having a very good accuracy. That's our end goal. So we are looking for a model which generates a brilliant results at the end of the day. Are you getting my point? Is this clear to everyone? Till so far, is this okay? So problem definition is done, data collection is done, data pre-processing is done, EDA is done, model building is done. Yes, we always build our own model only, Shaikh. It's like the model's implementation is already done in sklearn, but we will try to feed that model based on our data. So we will be having our own personalized model, which is available for us. In EDA, you will try to create the different plots and you will try to understand how the features impact each other. You will try to understand, for example, if let's say we will be having two features, whether those two features are positively correlated or not. You will try to understand the impact of one feature over another. You will try to see if there are any missing values available, how can you handle them? You will try to understand the distribution of the given data points that we have covered up in our yesterday's discussion, right? So whatever visuals you have discussed or you have seen in the last class, all of those visuals you will use in this EDA step, which will help you to understand the pattern of a given data. We will have to create the model from scratch or there would be available for every requirement. You don't need to create any model from scratch. As I have mentioned, in machine learning, we have another very interesting module called as sklearn. This is a very important module for the people who wants to work under machine learning. This module contains a lot many functions for the pre-processing part. This module contains lot many functions for the, I would say, algorithmic part to implement any algorithm, whether it's supervised or unsupervised. This specific sklearn contains a function to do a train test split or data splitting. So in this sense, in this way, we will be having for all the different steps that we are covering up right now in sklearn already inbuilt functions. We can directly use them and we can do our task in that sense. I hope it is clear to everyone. Any other question anyone is having? We don't decide the working of a model, like how it handles data for training. No. I mean, we won't decide it because it's like an algorithm we have. If you already aware about DSA subject, data structure algorithms. So over there also we have different algorithms. For example, dynamic programming, divide and conquer. So we have strategies, right? Similarly, we researchers have definitely made algorithms for us. We have to just think which specific model, which specific algorithm will suit for my requirement, for my problem statement. That's it. Yes, this is applicable for all the ML training. Okay. Just give me 1 second. I will bring my water back and then we will discuss the further steps. In the meantime, if you have any other question, just keep on writing in the chat window. Okay. Is this okay? Shall we move further? I'll take these questions which are apart from this discussion in the end of the session, researcher roadmap and all these things. If we are just using the existing models, isn't it like our work is a repetitive one? And now most repetitive tasks is being done by AI. Mm, I mean, it's not like that. I'm again saying when we are saying model building, we are applying the algorithms over here. So when what do you mean by algorithm? Algorithm means that we have a set of instructions. We know that, okay, how this linear regression will work. We have the internal implementation of that. How the logistic regression will work. We have the internal implementation of that. So whether you will write the model from scratch or you are fetching the inbuilt implementation of that model, it's one and the same thing. The main focus, if you understand in the entire pipeline, is on doing the pre-processing task, is on getting a final clean file at the end of the day. And yes, there are right now tools which can help us to do this task in a brilliant way, AI based tool that we have. But still, on top of it, a supervision is required. Still, on top of it, a domain level expertise, a tech level expertise will be required, which is something will be done by us. So we cannot rely on AI, but we can make use of AI to do our task in a more faster way. That's the whole point. Shaikh, how much maths is required? It would be great if you will join the today's discussion on my channel at 8 p.m. IST. I am talking about the same topic over there. ठीक है? All good? Shall we move further? Yep, YouTube. Is this fine? Is this okay? Shall we move further? All good? Now, when we talk about model building, once that model building part will be done, it's mine with my name only. I hope everybody knows till so far your mentor name. So you can search. Okay. Once the model building phase will be done, now you can move to the next step of model evaluation. You can move to the next step of model evaluation. What is the meaning of model evaluation? It simply means that now you have a model which will give you the prediction, but you have a target actual value also. For example, you are inserting the feature F1, feature F2, till let's say feature F8. We have 8 features, right? F9 is the outcome. So this is not an input feature. And based on that, let's say your model is giving a prediction that, hey, the model is diabetic. So this is a Y cap. But you also have a Y. In your test data, you also have a Y. Y means your actual output. Y cap means your predicted output. So over here, when you try to feed these features from F1 to F8, and you are getting the final predicted output as 1, but your actual output is 0. So in that specific context, this is what we called as an error. And if we have more errors, it means the accuracy will be very, very less. It means that our accuracy will be very, very less. So when we talk about the phase of model evaluation, in this specific case, we will try to see what is the overall accuracy of the model. So what is the overall error rate of my model? So obviously the error should be less, and in that case only our accuracy will be high. Exactly. Over here, we will give the unseen data to the model to check that how it is behaving. It's like I'm training you right now, but let's say tomorrow I will give you one exam. So obviously my intention will be कि whatever topics, whatever discussions I have done today, whatever questions I already have given you the answer today, I won't repeat those questions. I will ask you some different set of questions, considering the topic will remain the same, but question will be different. Context will remain the same, but the problem, the input values, input features, they are different. And based on that, we will be having a final outcome. Are you getting my point over here? Is this clear to everyone? All good? Shall we move further? चले आगे. Done. So we have seen data collection. We have seen problem definition. We have seen data collection. We have seen data pre-processing, then EDA, then model building, and finally model evaluation. In model evaluation, simply speaking, you will check how much is the error rate of your model. What is the meaning of error? Error means the difference between the output, actual output, and the predicted output. When the difference is huge, means error is high. When the difference is less, means the error is less. That's the whole point of model evaluation. We have to make sure that this model evaluation, this accuracy value should be very high. If it is not high, it means that you have to think again what could be the best thing you can do for EDA, what could be the best thing you can do for model training or model building. So, those steps you have to take care of. In model building, you are building your model, you are doing a training of your model, you are trying to make sure that your model will try to learn the pattern. It's like you are saying, Priya, what is the difference between I am learning in the class versus I am giving an exam in the class? They both are different. When you are saying I'm learning in the class, you're trying to identify the patterns, you're trying to learn the features. Based on that, your mind will get trained. When you're giving the exam, it means that over there, our main focus is to check how much error you are generating, how much accurate values you're writing in your exam, how much is the percentage you're gaining at the end of the day. मॉडल बिल्डिंग, मॉडल इवेल्युएशन. तो आप पहले समझते हो कॉन्सेप्ट को. समझना मतलब आप अपने दिमाग में उस कॉन्सेप्ट को बिल्ड कर रहे हो, आप ट्रेन कर रहे हो, वही मॉडल करता है. इवेल्युएट करने का मतलब जैसे आप पेपर देते हो, आपका रिजल्ट आता है, वो आपका इवेल्युएशन है कि आपने कितना सीखा एट द एंड ऑफ द डे. वो आपका एक रिजल्ट है कि इसके 60% आए, इसके 70% आए, इसके 90% आए, इसके 97% आए. तो जिसका जितना ज्यादा परसेंटेज आएगा मतलब उसको उतना ही अच्छा एक्सपर्टीज है. सेम चीज मॉडल्स के लिए भी लागू होती है. इज दिस ओके? इज दिस क्लियर? ऑल गुड? जैसे हम चेक हमें ये मेक श्योर करते हैं कि जब भी हम किसी भी लर्नर का एग्जाम लें तो जो क्वेश्चंस हम उसे दें वो क्वेश्चंस वो पहले से ना देख ले. इट शुड बी अनसीन फ्रॉम द लर्नर. जब आपके कॉलेज में आपके स्कूल्स में एग्जाम्स होते हैं तो कभी भी वो एग्जाम दिखा के नहीं देते ना कि क्वेश्चन पेपर आज ले जाओ, कल आप आके अटेम्प्ट करके जाना. ऐसा नहीं होता ना. इट इज समथिंग विच इज अनसीन फ्रॉम यू. तो आप पहले सीखते हो, आप पूरे साल समझते हो, उसके बाद आपका एक फाइनल एग्जाम होता है, उस एग्जाम के बेसिस पे इवेल्युएशन होता है. सेम थिंग इज हैपनिंग ओवर हियर. सो वी हैव अ मॉडल ट्रेनिंग फेज, we have a model evaluation phase. Is this okay now? Is this clear to everyone? All good? Finally, अगर आप मान लो अपने मॉडल से सेटिस्फाई हो, यू विल बी लाइक कि मेरी जो मॉडल की इवेल्युएशन मेट्रिक है, जो एक्यूरेसी है, वो काफी बढ़िया आ रही है. आई एम वेरी हैप्पी विद दैट. At the last stage, you will go ahead and do a model deployment. You will go ahead and do a model deployment. तो जो आपकी फाइल्स हैं, ट्रेनिंग फाइल्स हैं, उसको आप डिप्लॉय करते हो एट द एंड ऑफ द डे. यू विल ट्राई टू डिप्लॉय देम. आपने देखा होगा कि हमारे पास बहुत सारे एआई बेस्ड वेबसाइट्स आ गई हैं आजकल. चैटबॉट्स आ गए हैं. फॉर एग्जाम्पल मान लो डॉक्टर्स के लिए ही हम एक काम कर रहे हैं डायबिटिक प्रिडिक्शन का. तो डॉक्टर्स को हम ऑब्वियसली कोड तो देंगे नहीं, उनको कोड तो समझ में आएगा नहीं. दे डोंट हैव दैट नॉलेज ऑफ कोडिंग पार्ट. So what those doctors will take, those doctors we will try to give them the website. एक user interface website होगी जहां पे doctors can enter these numbers, doctors can enter these values. For example, pregnancies, whether the lady is pregnant or not, what's her glucose level, BP level, skin thickness level, insulin level, BMI level, diabetes pedigree function, it's what's her age. And based on that, जैसे ही वो outcome वाले बटन को क्लिक करें, so they will be able to get the outcome as either 0 or 1. So that's the whole point in this model deployment. Is this clear? What's the main difference between uh, model building मॉडल इवेल्युएशन एंड मॉडल डिप्लॉयमेंट. सो ओवर हियर जो भी आपका आपने मॉडल डिजाइन किया है, वट एवर बी योर model weights you have, whatever be your model weights you have, you will try to uh, create the website and check the overall predictions of the model. Is this okay? So this is basically for the user defined interface. मैं आपको एक अच्छा खासा रेफरेंस देती हूँ. अभी रिसेंटली मैंने आई हैव डन वन लाइव विद वन ऑफ माई लर्नर. हाँ, यूजिंग स्ट्रीमलाइट एंड फ्लास्क, दैट्स ट्रू. And he has built something amazing in terms of deployment part. You can have a look onto it maybe after this session will be over, and you will gain a better understanding of it कि कैसे हम एक final model create करके उसे deploy करते हैं. So we have a tools like Streamlit or Flask, with the help of which we will deploy the model. Is this clear? Is this okay? Yeah, there are many, so you can have a look onto it, but that's the main, I would say, end-to-end pipeline for any successful ML based system. So if now I will try to take a snapshot of what we have discussed, just check and let me know, is this clear or not? Just check and let me know, is this clear or not? So over here, we will be having, first of all, the problem definition. Then we have understood data collection. So problem definition means defining the goal, input, output, success metric. In data collection, we will gather the relevant reliable data. Then we have data preprocessing, where we will clean, transform the data. Then we have EDA, where we will try to understand the pattern and relationships. Then we have model building, where we will try to select the algorithm from the entire machine learning part. We will try to train and tune that. Then we have model evaluation, where we will evaluate our model on unseen data. Then we have model deployment, where we will try to make our model more accessible and scalable. And then finally, the last stage is monitoring and maintenance. This is also very important, where we will try to keep on doing the continuous improvement on the model. We will try to track the performance. We will do the retraining if required. Because when the data is scalable, when we will keep on adding the data, it might be the case that data distribution might get changed. And based on that, the kind of predictions that we are getting is not correct. So we will have to understand that at every point of time, the model will be able to give us a better accuracy. So in order to make sure that with respect to every test data, it is giving us a good result, we will have to monitor the performance. We will have to maintain the overall pipeline of the code. And that's what we have in the eighth step, monitoring and maintenance. Is this okay? Is this clear to everyone? So with this, um, our discussion on ML part is over. What is model deployment? I have mentioned over here. I think here also it's mentioned. Make model accessible and scalable. तो जब आप मॉडल जो आप ट्रेन करते हो उसकी एक फाइल क्रिएट होती है. तो जब आप उस फाइल को यूज करके वेबसाइट पे डिप्लॉय कर देते हो, डाल देते हो, तो होता क्या है कि एक इंटरफेस बन जाता है. अब हर कोई कोडिंग बैकग्राउंड से नहीं होता, तो आप क्या करोगे, आप उस वेबसाइट का लिंक दोगे और उस वेबसाइट के लिंक के बेसिस पे आपको वो इंटरनली वो मॉडल यूज करके प्रिडिक्शंस प्रोवाइड करेगा. फॉर एग्जाम्पल, बहुत लोगों ने देखा होगा कि आजकल इन मैनी प्लेटफॉर्म्स ऑफ अपस्टॉक, ग्रो, जीरोधा, and there are many online websites also जहाँ पे we can predict कि if let's say I will invest in some mutual fund, how much percentage of interest and the final amount I will get after let's say 5 years, or after let's say 10 years or 15 years of investment. So over here, if you will observe internally, there is a machine learning model which is going on. But on the top of website, we don't know internally what is happening. We have an interface जहाँ पे we just have to put the values कि I am investing 5 lakh for a span of 10 years in this mutual fund. It will give you final value कि after 10 years, what is your price? What is the final amount which you will be able to receive? Principal amount plus the interest value corresponding to it. समझ में आया? Is this okay? Is this clear to everyone? All good? That's the meaning of model deployment. तो सबसे लास्ट में हम मॉडल को डिप्लॉय कर देते हैं ताकि हमारे पास पूरी प्रॉपर एंड टू एंड वेबसाइट बन सके, ताकि अगर कोई बंदा नॉन टेक बैकग्राउंड से भी है, अगर किसी बंदे को डेटा साइंस या मॉडलिंग के बारे में कुछ भी नहीं पता, वो भी उस वेबसाइट को सीमलेसली यूज कर सके. जब हम बोलते हैं ना कि वी हैव अ एंड टू एंड एमएल प्रोडक्ट, दिस इज द एक्चुअल मीनिंग ऑफ दैट. प्रोडक्ट का मतलब होता है कि आपने अब एक ऐसी वेबसाइट क्रिएट कर ली है जहां पे आपने अपने मॉडल को, ट्रेंड मॉडल को, जो कि काफी अच्छी एक्यूरेसी दे रहा है, उसको डिप्लॉय कर दिया, उसको डाल दिया. अब आपको इंटरनली यूजर को नहीं पता कि कौन सा मॉडल काम कर रहा है मशीन लर्निंग का, क्या वो सुपरवाइज है या अनसुपरवाइज है. मॉडल को क्या कर, मतलब एज अ यूजर मेरे को क्या करना है. फॉर एग्जाम्पल, इफ आई ड्राइव अ कार, मुझे कार के इंटरनल्स नहीं पता और मुझे नॉलेज भी रखने की जरूरत नहीं है. मुझे तो बस ऊपर का इंटरफेस बता दो कि कहाँ पे कौन सा स्टेप पे क्या होता है, राइट, एंड आई विल बी एबल टू ड्राइव इट. कभी हम इतना इन डेप्थ नहीं जाते ना कि क्या इंजन है, किस लेवल पे इंटरनली ऑपरेट हो रहा है. गाड़ी खराब होती है तो हम गाड़ी वाले के पास जाते हैं और वो ठीक करवाते हैं, बट हम एक्सपर्ट नहीं बनते उसके. सिमिलरली डेटा साइंस का काम एक अलग है, टेक्निकल नॉलेज अलग है, but when you deliver something to the clients might not have the internal knowledge of it. So you have to deliver a end to end product of it जिससे कि वो as a user उसको use कर सके. That's the whole point. ठीक है? All good? From this part of a discussion, now we will start our new discussion and the second part of our today's discussion, which is about generative AI. And we will learn how in generative AI project the complete flow will be there. But before jumping towards that, if you have any questions till so far, please ask from me. Now, let's talk about what is generative AI. Generative. What is the meaning of this? Generative. It means that over here, the focus will be on generating the new content. The focus will be on generating the new content. That's why the name called as generative comes into picture. AI means obviously the content that you will be generating is somehow artificial. That's why AI full form is artificial intelligence, right? So generative AI is a domain where the core focus is on generating the new content. For example, I'm talking about textual data. I'm talking about image based data. I'm talking about music. And based on patterns, based on patterns, uh, definitely whatever the model has learned, based on that it will be able to generate all of these different types of data that we will be having. Now, always remember, when we talk about machine learning project or when we talk about machine learning algorithms, when we do a model training or when we do a model building, we always start from scratch. The training will always happen from scratch. But when we talk about generative AI, in this space, we have a concept of something called as pre-trained models. We have a concept of something called as pre-trained models. What is the meaning of pre-trained models? It simply means that you will be having a data, you will be having a model which is already trained on a very huge amount of data. So you will be having a model which is already trained on a very huge amount of data. And in generative AI space, you will use the pre-trained model and then you will try to get the final predictions. Okay? So there is a concept of pre-training, then there is a concept of fine-tuning. What is the meaning of fine-tune? Fine-tune means that for a given specific purpose, you will try to build the model end to end. So what you will do in generative AI, you have pre-trained model, you will use that pre-trained model, and on top of that, you will try to fine-tune your work. You will try to fine-tune your data. What does that mean? Let's try to understand that with some basic example. So let me first of all give you a snapshot on how the flow of generative AI looks like, and then we can proceed further. So what is happening? We have one foundation model available. We have one pre-trained model available. We will define the use case, whatever be the problem statement we are solving right now. For example, let's say you are writing a use case that you will give some features of an elephant and you want a picture of elephant at the end of the day. So what you want to generate and why you want to generate? Do you want to generate textual data? Do you want to generate image? For example, I have given the example of uh, creating an image of an elephant. Do you want to create an audio? You might have heard right now there are many people who are using this AI only to replicate the audios of other people, videos. There are so many videos in which generative AI is working, and in fact, you won't be able to differentiate between a actual human being and AI generated video. And sometimes you might have seen in your Instagram, in your YouTube shorts. Have you guys gone through with that? So whether it's about image, it's about audio, in fact, it's about video also right now. In all of these things, now what actually you want to generate based on that, uh, based on your use case, it will try to work accordingly. So with respect to every different use case, whether it's about textual data, it's about image based data, it's about audio, it's about video, we have a different, I would say, uh, pre-trained model. Again, I'm saying, is this clear what is pre-trained model? So if we will try to refer the formal definition of it, pre-trained models. So you can see a formal definition of this is, these are the artificial intelligence models previously trained on massive general purpose data set to learn the features, allowing them to reuse or fine tune them for specific related task. So that is the formal definition of pre-trained models, which is very important to understand. So you can imagine that we will be having a model which is trained on a very huge chunk of data, very bigger size of data, and we are trying to reuse that, we are trying to fine tune that for a given task. So if let's say you want to generate a textual data, if let's say we want to generate image based data, we want to generate audio or video, based on that we will be having a different set of pre-trained models which we will be using. Examples, there are so many examples. For example, transformers, BERT, GRU, GPTs, GPT 3.1, GPT 4, GPT 5, I think is the recent one. All of these are the pre-trained models we have. So if you want to see the list of pre-trained models for generative AI, so you can see all of these are the pre-trained models which we have. So you can find a complete list of this. Top 5 pre-trained models: BERT, GPT, Elmo, Transformer, Roberta. There are many more. And every pre-trained model has its unique capability. Depending upon what specific use case you are solving, accordingly, you have to see which specific pre-trained model is already trained for that specific use case, and you will pick that specific pre-trained model only to do to do that specific task. Is this fine? Is this clear to everyone? All good? So we'll define the use case, what to generate and why. The second step is data curation and preparation. Now, once we understand the business use case, similar to what we have learned in machine learning, as per that, we have to collect our data. We have to understand and collect the domain specific examples, whatever is our use case according to that. Once that part is done, the next part is model selection and fine tuning. It is very important. Now we have pre-trained model, that is a foundation model, that's the base model we have. Now what we will do, we will try to adapt that pre-trained model to our domain, to our use case, what we want to do actually. So you can consider this brain over here as the pre-trained model. This is your own model, your own data. And finally, you will be able to see a combination of both of them. So if I will just try to showcase you a formal definition of fine tuning. Sorry. So if we will see the definition of fine tuning for generative AI, so you can see fine tuning in generative AI is the process of further training a pre-trained foundation model like GPT, Llama on a smaller domain specific data set to enhance its accuracy, tone, specialization for niche tasks. That's the meaning of fine tuning. That's the meaning of fine tuning. So you have a pre-trained model available. On top of it, you have one specific task. You have one specialized task. So what you will do on top of this GPT, on top of this pre-trained model, you will add your own data so that you will be able to get your own specific model. A very good example of this, I don't know how many of you have heard about Dr. GPT. Have you heard about that? Dr. GPT. किसने सुना? I don't know whether I'll get some information on the web, but let's try. Dr. GPT. So if I'll just click over here with my account, this Dr. GPT will get open. But I just want to showcase you its definition. So you can see Dr. GPT refers to several distinct AI driven medical and technical projects, ranging from clinical assistant for healthcare professionals to software debugging tools. Medical and clinical AI. So we have clinical assistants, we have Chinese medical LLMs, general medical Q&A module. So basically, what actually is happening over here? We have one generic chat GPT, that is fine. But when chat GPT was came into picture, at that point of time, medical people have given a thought that why not we will create our specialized doctor GPT. And right now in lot many private hospitals, you will observe that they have this specialized GPT available for their specialization. For example, if there is a surgeon department, for them they have a specialized GPT available. If it's a gynae department, they have a specialized GPT available, which is somehow helping the doctors to do the task in a more seamless way. For the physicians, there is a separate GPT available. So basically, over here, what is happening is medical and technical project. So basically, we have a chat GPT, we have a GPT, which is a pre-trained model. On top of it, I will try to train the medical data now. I will try to train specially the medical data, a specific data set, so that I have a fixed niche of my GPT, which is a doctor GPT. So basically, what is happening is we have a pre-trained model of GPT. On top of it, we're adding the medical data. Now I have the capabilities of that pre-trained model and a specialized niche of medical data. So we are doing a model selection and we are doing a fine tuning on it. Is this clear to everyone? Is it clear to everyone? So let me see the question. Is it like connecting APIs and creating in custom chatbots using a filettes for major access of knowledge? Yes, somehow you can think like that. Yep. Is this okay? But this specific step in the world of generative AI is called as fine tuning. So is this clear? Pre-training, what does that mean? Fine tuning, what does that mean? Are we good to go further? Are we good to go further? Next step is prompt engineering and testing. So what we are doing over here? Once we have, let's say, Dr. GPT, just like the way I have showcased you, we will write different sort of medical prompts over there. And we will test, doctors will test that whether the Dr. GPT will be able to give a better results or not. The results are insightful or not. So they will test that whatever be the questions they're asking, consider that Dr. GPT is a doctor. So whether it is giving a proper diagnosis for that or not, proper recommendations to the patients or not, proper prescriptions to the patients or not. So prompt engineering means writing an effective prompt and then checking that whether the model will be giving an appropriate result corresponding to it or not. So that's the fourth step. Once the prompt engineering and testing will be done, we will try to evaluate our model. Again, the same thing that we have learned in machine learning. We will try to see the error rate. We will try to see the quality of the result. We will try to see whether the results are relevant or not. And once we are satisfied with the evaluation part, the final thing is to deploy the model and to monitor its performance. So same thing that we have learned in machine learning. For example, right now, we have OpenAI APIs with the help of which you can do predictions. But for that, you have to write a code, you need to hit the API, all of those things you have to do in order to get the result. But are you doing like that? No. We have some interface of ChatGPT on which we are writing the prompt and we're getting the solution. Now we don't know internally what specific code is being used to hit that API and give us the final result. So similar to that, whenever we design any generative AI application, any Gen AI specific product, what we want at the end of the day is we want a final end-to-end product with the help of which we will be able to get the insights. So you will be having one website. You will say that, can you give me an image or a textual data or a code? It will go inside that specific model, and based on that, it will generate the output. So generative AI systems are guided, they are evaluated, they are refined, and not left unattended. Is this clear how the entire pipeline of generative AI development is being done? So we start with the understanding of a use case. Then, as per the given use case, we collect our data and we prepare our data. In the third part, we take the pre trained models as a foundation model. On top of it, we try to fine tune it. We have understood pre training means that we are having already previously trained models which are trained on a very huge amount of data. As per my business use case, I have to select which specific pre-trained model is best for my task. On top of it, we'll do fine tuning. Fine tuning means we are doing a specialization now based on our specific data set. I have given you a real-time example of Dr. GPT where we have a GPT model. On top of it, I'm just feeding a medical specific data so that my model is specialized with a medical specific work. If I will ask from that Dr. GPT any disease part, any prescription, any discomfort, if I will explain, my Dr. GPT will be able to give me the recommendations just like the way doctor used to give to me. Now, few people might have that misconception key in that case, though we don't even visit to the doctors. If we have these kind of platforms available, still we cannot rely 100% on these specific platforms. Obviously, doctor intervention will come into picture. That is where the testing, the evaluation is actually done by domain experts, by doctors only. Because if there is something wrong, they will mention, there will be a more repercussions on that part. So we will have to make sure that whatever be the model is giving as a response, it should be appropriate. And till so far, I mean, we cannot 100% rely on that's for sure. Maybe after few years, I don't know how the things will look like. But right now, definitely, as a human being, we don't have that much level of trust. For small sort of diseases, definitely we can take a recommendation. But for a higher level of concerns, we have to visit the doctors, and that's a good approach as well. Yes, for doctors it is beneficial because it's kind of one level of result which can be given by these models, and on top of it they can improvise it. At the very end of the day, once doctors are satisfied with the results in this specific case study, they will definitely prefer key we will have one specific platform where we can ask any question and automatically it will be able to generate the response as per that. So that's the overall scenario with respect to the generative AI development flow. Is this clear to everyone? All good? Can I get a quick confirmation over here? Perfect. Now, the last thing, when we work in the industries, we will encounter a lot of business problems. But when I'm saying that we will start with the understanding of problem statement, whether it's about generative AI or it's about machine learning part, there is one very important thing. As a person who is from data science background, our very important key thing is to translate any business problem into data problem, into data specific problem. What does that mean? It simply means that if, let's say, you have any business question, obviously your clients, your stakeholders will provide you a business context of it. But what you have to do is you try to work around with it, and you have to make sure that you will be able to convert that problem into a way which is measurable. Then only you will be able to solve that problem, right? Which is kind of solvable. using the data. And that's the end goal that we have to achieve. So if I will talk about both of these things, the business problem and how can we convert that into a data problem, if I will give you the example of this, so see this snapshot. So you can see over here, what is happening is the business question could be, can we reduce the churn? How many units we will sell? Or can we automate this content creation? Right? This could be a business problem. But now you have to think that how can you convert this business goal to a data driven solution? You will try to understand the context. You will try to identify the data. You will define what could be the output measure you will be having. You will define the success metric as per that. So, a good data science starts with the right business question. So, as a client, you will have to give the problem statement to the data scientist people. As a data scientist, your main goal is to convert that business problem to data science problem. For example, whether the customer churning will happen or not, whether the demand forecasting will be there or not, what's the kind of a trend will be there. Customer clustering. I have given the example of customer segmentation in today's discussion. That same thing. Text generation with generative AI, right? Can we automate content creation? Obviously, over there, the domain of text generation with generative AI will come into picture. How many units will we sell? Over here, maybe the customer clustering will come into picture. Can we reduce the churn? Maybe over here, the churn prediction will come into picture. I think both of these examples I have shared with you in the starting of the discussion as well. So, based on a given problem statement, how can we convert that into a specific data problem? That's the art of people who wants to work under this data science domain. Okay? Now, what are the steps to translate this effectively? How can you translate this business problem to a data specific problem? So you can see this over here. First step is you have to think, understand the business context. You will think what decision will this help me to improve. Then you identify the data sources. What data do we already have and what do we need? Then you will clarify the output. Are we predicting? Are we classifying? Are we generating something? Then you will define the success. Success means what is the final evaluation metric which I will use over here to define the accuracy, to define the revenue impact, to define other important measurables. So that is how we will be able to translate any specific business use case to a data science problem. Yes, you must have a deep understanding of a business as well. And that's why it's being always said that in data science specific domain expertise also plays a very important role. And that's why you might have heard that there are so many companies who don't hire data science people as a fresher. The main reason was this domain expertise. So when we talk about freshers, they don't have that domain expertise. And that's the main reason why companies feel ki if we get some experienced people, that would be better as comparable to the freshers. But at the same time, there are many companies who definitely hire the people and train them to get that domain level expertise, and then they will give them the task to work further. Right? So that's the overall idea about what we have in machine learning versus what we have in generative AI. Is this something clear to everyone? All good? So this is about how can you, I'm saying to you that you have to convert the business questions to data science problems. So the point is, how can we convert them? So over here, first of all, you have to understand the business context. You need to understand what actually clients are expecting from you. What decision will help them to improvise their business. Then secondly, you need to identify data sources. If you understand the business problem, the next step is data collection. So you need to think that how you will able to access the data. How will you able to pre-process that and do the EDA for that? The third important thing is to clarify the output. What is the end goal you want to do? Do you want to think about prediction? So, is that a classification task do you want to do? Do you want to automate some text generation part? So, are you going towards generative AI thing? Do you want to tackle some image classification task? Are you going towards deep learning stuff? So, that is very important. Key, are we predicting? Are we doing any classification task or are we generating something out of it? And finally, the last important thing which you should have in your head whenever you are starting any data science project is ki which specific evaluation metric should I use? Uh, Maybe accuracy will work better, or revenue will work better, or precision will work better, or recall will work better. And depending upon that, you will be able to give the insights and the response to the clients on your work. So that's the overall idea about today's discussion, where we have focused on machine learning. What do we mean by that? It's end to end workflow or life cycle, I would say. And after that, we discussed about generative AI, how generative AI is a bit different from ML stuff. What is the complete end to end pipeline for generative AI work? And by the end of the discussion, we have talked about how can we convert any business problem to a data science problem. What are the steps that we have, which we have to do effectively to get our task done?